Okay, so today we are learning an incredibly important concept. This is something that you're going to need to know from now until the end of your days in chemistry. It's something called formula weight. It is a new topic. The formula weight has a bunch of names. They all mean the same thing. So sometimes you'll see it written as formula weight. Sometimes you'll see it as the abbreviation FW. That's the one that I like best. Because to me it describes most perfectly what you're trying to accomplish. So here are its aliases. It also goes by the name molecular weight. And then it is abbreviated MW. Not everything is a molecule though, so that's why I prefer not to use molecular weight as a term, as its like name. It also goes by the name molar mass. Which is fairly descriptive, but you have to know about chemistry a little bit in order to figure out what a molar mass is. And then the last thing, like the last name that it could have would be compound weight. But I don't like that as much either because it implies that it's like how much it weighs. And that can be a different concept depending on what you're thinking about. Okay, so formula weight is actually incredibly easy. It's just so important that I want to spend a whole day just talking about it. In fact, I don't think this will take more than 5 minutes for me to teach you how to do, because it's pretty simple. Okay, so what I want you to do is look at your periodic table, and I am going to pull one element off of here. Let's take a look at our friend sulfur. So I'm just writing like a big version of what I'm looking at on my periodic table. So obviously S is the element symbol, right? And sulfur is its name. There are two numbers on the periodic table on the front side of the one that I made you. Other periodic tables have a bunch of other information as well. This is just the most essential. 16 is your number of, yes, your number of protons. That's the atomic number. It's what defines what your atom's name is. So if your atom has 16 protons, it's automatically sulfur. The other number is what we're going to use today, and that's the decimal place number. This is the atomic mass, or the atomic weight of the element. How do we get that number? That number is given to us by a weighted average of all of the different isotopes in existence in the universe of that element. So obviously, since we've only been to one very small corner of the entire universe, do any of you know how big the universe is? It's 153 billion with a B light years across. So to go from one end of the universe to the other, it would take you 153 billion light years to traverse that kind of a distance.
How many years is a light year?
What?
How many million?
Well, that would be like a nonsensical number.
A few?
Well, 153 billion years.
So how many years is a light years?
A light, right, yes. Say that again, Dominic.
Light years.
In a year, right. So, it's the same thing for us, for our purposes, it's the same thing as saying it's 153 billion years. That's a nonsensical number, like in the course of human history. Like, that's just too big. Okay, so this is the number that we'll be using today to calculate all of our formula weights. So then, what is a formula weight? when you're given a compound's formula, okay, so let's take a compound that would have sulfur in it. Let's do sulfur dichloride. Here's our compound's formula. So now, yeah, that's a Cl2. So now, the way we calculate formula weight is to just add up all of the atomic weights of every single atom that's in this formula. It's a lot easier than it sounds. So sulfur, we just decided, has a formula weight of 32.06. How do I know that? It's on the periodic table. Chlorine has an atomic weight of 35.45. That's a Cl. I'm sorry. I don't know how else to write it. But how many chlorines are in this formula? 2. So we have to account for that by multiplying the 35.45 by 2. All right, so now that we know these things, all we do is add 32.06 plus 2 times 35.45, and that is our answer. I get for my answer 102.96. Is that what you got as well? Sure. Sure. All right, so a couple of things. After this first test, we're going to start learning about significant figures. Is that a word you've ever heard before?
Yeah.
Okay, good. But for right now, you don't need to know anything about significant figures, but you do need to know that whenever I ask you for a formula weight, I need 2 decimal places. Always. So if you take a look at your homework number 4, on page 4, it'll even tell you that to use the correct number of decimal places is essential if you want all the points for those questions. So I need 2 decimal places. Do I have 2 decimal places here?
Yeah.
Okay, so then we're good. But you also need a unit, because a number without a unit is meaningless, right? Your unit for this is going to be something a little bit weird. I don't need you to know what it is. I just need you to know that you need to write it. The unit is called grams per mole. And the way we spell mole is M-O-L. Not M-O-L-E, but M-O-L. It's very specific. So make sure that you include that. You don't need to know what that means, but you need to have it. All right, so I would like to do a couple of these problems with you so that you have some correct answers on your homework to get you started. All right. The first one I would like to do is number 4.
4.
I am going to skip around a little bit.
Oh, is this on the back side? It's on the back, man.
It's on the back side of homework number 4. Oh, no.
Yeah, I wasn't here, so. Unless you
That's
didn't.
right. That's right. No, I didn't.
Johnny.
You will look up that. I think you'll be able to manage it. It's not very much. All right, so that's a good question. Na is the element. Okay, good. Now, what's its atomic weight?
22.99.
That's good. All right, now what is oxygen?
16.
16.00. All right, so do you see how I did that? Somebody said to me, well, what's OH? OH is really hydroxide if we're looking at our pink sheet. But we have to, every time you see a new capital letter, that's the start of an element. So I can't find the formula weight from looking at the pink sheet. I have to take every single element individually off of the periodic table. Hydrogen is 1.01, right?
Yeah. Yep.
Okay, are there multiples of any of these elements in the compound?
No.
So what should we do?
Add them up.
That's it.
Add them up.
All right, do that.
40.
It's a good 40. 38.
40.
It's 40. Okay, but
We're gonna add that other stuff.
What's on the sheet?
how many decimal places does this John need?
2.
Yes, we have to put 0, 0.
Cheapo.
And then our unit is grams per mole. Or G/mole is fine. However you want to think about it, I just need you to write it. All right, so now let's do something that's a little, how are we feeling? This is doing okay? It's easy so far? Okay. Thank you, Jesus. All right, let's do something tricky. Let's look at number 10. Is iron 3 hydroxide. Okay, so iron is my first element. Its formula weight is 0.84, correct? Oxygen we just did, it has a formula weight of 16.00. Hydrogen we just did as well. You might find that some sad things are happening in your mind while you're working on these things, and you might discover that you have some of these things memorized just because you've used them so much. Okay, but can we just add all these numbers? We can't. So we need to know what this 3 means about this parentheses. So it means really that you've got 3 of this whole thing. You have to multiply the oxygen by 3 and the hydrogens by 3. You could, yeah, you can. You can. I'm a lazy person, so I'm not willing to type that many things in my calculator. So for this problem, you should get as an answer, anybody?
106.87. I got 106.87.
I also got 106.87. So if you're typing all those numbers in then, guys, every time you type in a number on your calculator, you're introducing a source of error. Your own human error. Because you made a oopsie-boopsie. Gmol. At the end. I mean, it's technically most correct to do this for all of them, but I don't even need you to show me your work. I don't even need you to show me your work. Nope.
Yeah, we don't even need to show the work.
You don't need to, nope. If you would like to, because it helps you to like make sense of it in your mind, go for it. All right, do you want me to help you do the hardest one on here?
Is it 14? 14.
Yeah, let's do 14.
Is that the hardest one?
I mean, 11 looks a little hard too.
11 is easy.
Just out.
Okay, so what does the parentheses mean, gentlemen? Hunter,
Yes.
don't make the sound with your chair.
I didn't mean to.
I have a suspicion that it was you
I didn't mean to.
who was touching the tape measures the day when I absolutely lost my mind.
I didn't. Okay, it was me. And that's because I was excited and it fell over on itself.
Yeah, that's what killed you. Jared, stop poking the bear.
I didn't get one thrown at me.
All right, so what does this parentheses mean here?
It's
Elliot?
too low.
There's 2 and then 8.
8 H's. Yes, because what you're saying is that you have NH4, NH4. So whatever your number is outside the parentheses, you want to multiply by everything inside the parentheses. We have 1 carbon, but how many oxygens are there? How many?
3.
Carter, you're going to have to keep your booty in that seat, please. You guys are awfully goofy after lunch here. I don't know that I care for this. Although I was just complaining today to Nick Luna about how few of dollars we've been able to raise so far on the dollar board. I thought having 2 Aidens in my class in 4th block general chemistry would just be an absolute gold mine for the poor, but it hasn't been.
Stop blaming Jordan.
Do you need help with dollars on the dollar board? Sick and AJ apparently has.
Are you trying to be immature and funny?
Well, so then we reminisced a little bit about Nick Luna and how he got like $20 in one day. That time when he was given Jacob Nadel, like he had him like face down where Sawyer is, like but like face down on the with his head like on the bench, and he was aggressively backshotting him. Like, it was some incredible violence.
This is freaky, dude.
Freaky, just absolute freaky thing.
No, I would not. I aggressively.
I don't think we need to repeat that.
That's deep.
Oh, that's one.
I didn't say it.
I know you did it, but somebody did.
So I lose one of my tests.
Wait, you said video machine?
Hunter. Oh no! How did that happen? My sleeve got it. Hunter has a Diddy quota. He can only say it 10 times. Yes, Sawyer. Oh, that's a good question. Because Sawyer, when you have this 2 on the outside of this parentheses, what you're really saying is that you have one AH4 and another one. So 4 plus 4 is 8, or 4 times 2 is 8. So whatever your number is outside the parentheses, you want to multiply that by everything in the parentheses. Anybody get an answer for this?
72.02.
What? Elliot, what did you get?
That's what I got. Chad, you might go.
All right, let me look. I'll verificate.
I got 72.02.
I think, Hunter, that might not be right.
It might be.
It might be.
Wait, you have to divide by 7?
I got this too.
Why did you divide by 7?
No, I don't know where this is coming from. This is just like what it equals. 96.11 grams per mole.
Oh, that's what I thought. So close.
Wait, Hunter only can say 3 days.
10
Per day, 10 ditties per day.
I've only used one so far.
No, I'm not even mad.
He just was saying it like every other word, and it got old. It got old. All right, I don't have anything more for you. Do you guys have any questions about this? All right, then let me give you your lab and.